Dear students, in today's lecture, we will discuss several basic problems of probability based over addition and multiplication theorem. Question number 1. Three groups of children contain respectively 3 girls, 1 boy, 2 girls, 2 boys, 1 girl, 3 boys. There are 3 different groups having different number of boys and girls. One child is selected at random from each group, that is from first group, second group and third group. Show that the chance that the 3 children selected. Why 3? Because 1 from first group, 1 from second and 1 from third. So totally 3 children selected. Consist of 1 girl and 2 boys is 13 by 32 is what we have to prove. Probability of doing that is equals to 13 by 32. First of all, we have to think over the possible options for fulfilling the requirement. Requirement is to select 3 children with 1 girl and 2 boys, 1 from each group. It can be done in 3 ways. How? That 1 girl can be selected from first group, then 2 boys from other 2 groups, or the 1 girl may be from second group, then 2 boys from other 2 groups and 1 girl from third group and 2 boys from other 2 groups. So 3 possible options are there. Wherever we have multiple possible options, alternative options are available for fulfilling the requirement of the problem, then it is confirmed that we have to use addition theorem of probability in solution of that problem. We will see it in detail in the solution. We start with say 3 groups 1, 2, 3, the details are given, and I was mentioning 3 possible options for providing the requirement, fulfilling the requirement. Case 1, 2 and 3 are those options. That 1 girl is taken from group 1 and then 2 boys are from second and third group, 1 girl from second group, second case 1 girl from second group and boys are from first third group, and third case 1 girl from third group and boys are from first second group. So 3 possible options, and here we have group details. In group 1 we have 3 girls, 1 boy, group 2 is having 2 girls, 2 boys, and group 3 is with 1 girl and 3 boys. Now we can find individual probabilities initially. PB1 means probability of boy from group 1, as you can see group I for I1, 2, 3, that is 1, 2 and 3 are the subscript showing the group here, and B and G boys and girls. So PB1 means boy selected from group 1 where 1 boy and 3 girls are there, so obviously it's 1 by 4 the probability of this, and PG1 girl selected from group 1, it has to be 3 by 4. Similarly PB2, PG2 from second group and PB3 and PG3 from third group can easily be obtained. And finally we have 3 possible solutions, alternative solutions. So finally we have to find this requirement is fulfilled by any of these 3 options. That's why addition theorem is required, because addition theorem is PA union B union C, means A or B or C. At least one of them happens, then the solution is obtained. So in any one case out of these 3 the solution is obtained, and these 3 cases are mutually disjoint. Why? Because if case 1 happens, second, third can't. If second happens, first, third can't. If third happens, first, second can't. So only one can happen at a time. So addition theorem for P case 1, final required probability is P case 1 union case 2 union case 3. And we know that PA union B union C is equals to PA plus BB plus PC when ABC are mutually disjoint. This is the case here. So finally the probability will be P first case plus P second case plus P third case, as you can see in that final step. But for that we need to calculate P first case, P second case and P third case. Before that, what we are doing there, P first case, and first case is 1 girl from group 1 and 2 boys from 1 girl from group 1, 2 boys from second and third group. So PG1, PG2, P. Here we are using multiplication theorem also. 2 theorems are applied together. Multiplication, why? Because P first case means PG1 intersection, that is AND B2 and B3, but that selection is quite independent. That's why PG1 intersection B2 intersection B3 is written as PG1 into PB2 into PB3. We know that PE1 intersection E2 is PE1 into P2 if E1 and E2 are independent. It can be set for 2, 3, 4 any number of events. So using that independency, the multiplication theorem is written for P first case, and we know about that is these individual results. PG1 is 3 by 4, PB2 is 2 by 4, PB3 is 3 by 4, so multiplying all 3 it's 9 by 32. Similarly P second case is P, in second case we have B1 and G2 and B3. So it's P B1 P G2 into P B3 using multiplication theorem with independent events P1 G2 and P3. And similarly third case is also P probability of third case is also obtained, and then as I was discussing, P first case plus P second case plus P third case using addition theorem, that is 9 by 32 plus 3 by 32 plus 1 by 32 is nothing but 13 by 32. Question number 2. The two computers A and B are to be marketed. A salesman who is assigned the job of finding customers for them has 60% and 40% chances, that is probability respectively, of succeeding in case of computers A and B. The two computers can be sold independently. Given that he was able to sell at least one computer, what is the probability that computer A has been sold? Let's start with assuming some event. Let X be an event that computer A is marketed and Y be an event that computer B is marketed. Then Px as given 60% and 40% chances respectively for marketing of A and B computers. So Px is 0.60 and Py is 0.40, and it is obvious to say that Px bar is 1 minus 0.60 means 0.40 and Py bar is 1 minus 0.40, that is 0.60. These are initial results. It is important to discuss what is required in this particular problem. Let us discuss it with that statement. Given that means which already happened. Given that he was able to sell at least one computer, that means at least one means one or more. So whenever this word at least one or A or B, you have to understand meaning of PA union B, that is addition theorem. PA union B always means P, A or B. It also means P of probability of at least one out of A and B. Same can be said for PA union B union C, that is three events, that is PA or B or C, or we can say P, that is probability of happening at least one out of A, B and C. So whenever we talk about this at least one, that means it is about addition case. So given that it already happened, and then you have to find the probability that computer A has been sold. That's why the required probability is conditional probability. In conditional probability, P A upon B, theoretically if I speak P A upon B, then it actually means that B already happened, and A, we have to find the probability of happening of A after happening of B. And here, which already occurred, given that he was able to sell at least one computer, that is X union Y, at least one means X union Y, addition theorem, what I was discussing, already occurred, and after that I have to find the probability of computer A has been sold means X, what I assumed there. So Px upon X union Y is the required probability, and we have the formula PA upon B is PA intersection B upon PB, and using that formula it becomes P A intersection B in numerator. A is given as X and B as X union Y. So A intersection B means X intersection X union Y upon PB means P of X union Y. It is further equals to Px Yx, because that numerator X intersection X union Y, as per simple set theory you can find it, it is that event equals to X. That's why numerator equals to P of X, that is probability of X upon P X union Y, and it is also equals to Px and numerator same, and Px union Y means happening of either X or Y, or at least one of X and Y, X or Y, is always equals to 1 minus P X bar intersection Y bar, that is neither X happening nor Y happening, and we are subtracting it from 1, so it always equals to Px union Y. You have to remember this formula also as different form of addition formula. Then Px upon, it is 1 minus Px bar into pi Py bar. Why? Because intersection means multiplication theorem is coming in the picture, and as given sold independently means events are independent, and if events are independent, so it is PA intersection B is simply PA into PB. That's why Px bar intersection B bar is Px bar into Py bar. we have now have all these values: px 0.60, px bar 0.40, py bar 0.60. So let us substitute all these values. Finally it is equals to 0.79. Question number 3. A and B take turns in throwing 2 dice, and the person who throws 9 first is to be awarded a prize. That is, 2 players A and B playing a game in which they are throwing a set of 2 dice, and they are counting the sum of numbers over those 2 dice, and if that number or sum comes as 9, then one of them wins the game. And show that if A has the first turn, that means A starts the game, the chances of winning the prize are in the ratio 9:8. First of all, we calculate the probability of the experiment, that is getting 9 in a throw of 2 dice. That is, total number of cases in throwing 2 dice are 36, and for finding sum as 9, there are only 4 favorable cases. That is 3 plus 6, 6 plus 3, 4 plus 5, and 5 plus 4 as sum of numbers. So 4 upon 36 means 1 upon 9 is the probability of throwing 9 in throw of 2 dice. Fine. Let E be the event of getting 9 in a throw of 2 dice. So we can officially say PE is equals to 1 upon 9, and if it's not happening, so PE bar is 1 minus 1 by 9, that is 8 upon 9. Why we use this also, we will see it in next step. Probability of winning of A. Now winning of A is actually available in multiple options. How? Say A can win, as he is starting game, he can win in first attempt. Maybe if he does not win, then he will not throw 9, and then B will start his turn and he will also not throw 9. So A fails and B fails, and then turn of A comes again, and then he throw 9, then he may win. That is, A may win in first attempt or in third attempt after failure of first and second attempts by A and B, and if not, then he may win in fifth attempt after 4 failures, 2 by A and 2 by B continuously, up to infinite. So that is, we are thinking over winning probability of winning of A only. In that case, it is about multiple possible options. That means whenever we have multiple possible options of solution, that means addition theorem comes in the picture. That is, P winning of A is P probability E. That means if 9 comes in first attempt, union, that is OR. If not, then first and second attempt are failure by A and B, and intersection E, that is in third attempt 9 comes, and third turn means turn of A. If not, union, or first, second, third, fourth attempt failure of A, then failure of B, failure of A, and failure of B, intersection, then in fifth attempt 9 comes for A, it's A's turn, union, or up to infinite. So that is about addition theorem in picture. And then these all cases are mutually exclusive. That is, if it happens, next and next will not happen. If it happens, first will not be happen, and that is, only one of these can happen at a time. So PA union, B union, CA union up to infinite. Addition theorem with mutually exclusive cases is PA plus BB plus BC plus BD, etc. So PE plus PE bar intersection E bar intersection E. Actually, it is under multiplication theorem, PE bar intersection E bar intersection E, but these all are independent events. In no turn, nobody depends upon throw of previous throw of other player or himself. That means all independent events. That's why in independent case, PA intersection B intersection is C is PA into PB into PC. That's why it's PE bar into PE bar into PE. Then plus, as addition theorem is going on, and then it's again product of 5 separate PE bar, PE bar, PE bar, PE bar into PE. Now PE value of that is 1 by 9 plus PE bar, PE bar, all values are there, 1 by 9, 8 by 9 at several times. 1 by 9 is taken as common, then it's 1 plus 8 by 9 whole square plus 8 by 9 whole power 4 plus up to infinite. And after that 1 by 9, in that bracket we have a geometric progression GP up, and we have to find its sum up to infinite terms with common ratio 8 by 9 whole square, that is 64 by 80, 1 is its common ratio. And we know about the formula A upon 1 minus R. First term A, R is common ratio. So 1 upon 9 outside, first term is 1 upon 1 minus common ratio is 8 by 9 whole square. and if we simplify it is 1 minus 64 by 81, 81 taken in numerator, 81 minus 64 is 17. So finally it is simplified at 9 by 17. Probability of winning of A is 9 by 17 and sum of winning of A and B is 1. So winning of B is 1 minus 9 by 17. That is 8 by 17. If there may have be a group of 3 players A, B and C, then A may win in first attempt, fourth attempt, because A, B, C 3 players are playing. Okay, arbitrary situation what I am discussing. Or if not, then A may win in 7th attempt, 6 failures by A, B, C. So in that case we have to calculate A winning of probability of A in some different form of this, and then we have to calculate probability of winning of B also separately, and then winning of C is 1 minus winning of A and winning of B, that can be subtracted. But here only 2 players, so winning of A is there, so winning of B is 1 minus winning of A, that is 1 minus 9 by 17, 8 by 17. What we have to find? Chances of winning of A and B, that has to come under this ratio 9:8. So it's the ratio of chances of A and B winning the prize, that is ratio of these probabilities 9 by 17 is to 8 by 17, simplified as 9:8. So it is about first lecture regarding probability, in which we discussed addition theorem and multiplication theorem and their mix up in many problems. In next lecture of probability we will discuss Bayes theorem, all important theorem regarding conditional probabilities for probability.